Hey all, this is Alan with Bothell STEM Coach, and today we are doing another AP Calculus related rates problem here. So again, these are sort of more challenging related rate problems, and I find students have different teachers that are, some give harder problems, some give easier problems. These in general will be a little bit harder than what you'll see on the AP Calculus, but you should be able to do them. So I suggest you pause the video, attempt to do the problem, and then come back after you've attempted the problem. So you have an airplane that has a height 30,000 feet directly above you, moving at a constant speed. It's changing angles at a rate of pi over 36 radians per second. What is the ground speed of the airplane? I should have put a picture in here. It probably would have helped a little bit, but let's draw a diagram of what's happening. I got a little airplane here. We'll just say the airplane is I don't want to draw an airplane, but you guys can be awe-impressed by my my drawing skills. It's 30,000 feet. And what they're saying is this angle, let's say it's making an angle here, like as it's moving this way, it's making an angle, theta. So let's just be clear. 30,000 refers to this side here, like how high it is above the ground. We're going to assume it's flying horizontally. So it makes some angle. And so I want to figure out like a few parameters here. So we're going to say h is equal to 30,000. And it'll be this side of the triangle. You know, this kind of makes a triangle. I'm given that d theta dt, this is the rate of change, is equal to pi over 36. So it's increasing, pi over 36, a constant angle. I don't know why it's constant angle. Maybe it's changing at that angle right at that point, but that's fine. And the question is what is the ground speed? Let's talk about how fast it's moving here. We'll call it x. The question is what is dx dt equal to? Okay. So the setup is the trickiest part. Is you have to establish your variables and decide what's changing with everything. Okay. So I want an equation that relates h, theta, and x in some form or another. And if you think about it a little bit, and you think about your pre-calculus, I know that this is a right triangle, right? And I can do tangent of theta relates the opposite to the adjacent side. It's equal to x over h. But h is constant, so it's equal to x over 30,000. Okay? And I can multiply the 30,000, so I get x is equal to 30,000 tangent of theta. And now I take the derivative, dx dt is equal to 30,000. Oh, derivative tangent is secant squared theta. But because this inside is not t, because I'm taking the derivative with respect to t, time, this is a function of time, it's going to do d theta dt. Okay. So this is what I'm trying to solve for, so I need to do this. I know theta. Well, I don't know the theta. Let's think about what theta is. When it's directly overhead, theta is 0, right? Because it's 0 angled when it's directly overhead. What is the ground speed of the airplane? So we're going to do 30,000 secant squared of 0 times d theta dt. I just wrote the exact same thing. What's the secant squared of 0? Sorry, instead of d theta dt, I'm going to put the actual number, which is pi over 36. Well, secant is 1 over cosine. Cosine of 0 is 1. 1 over 1 is 1. 1 squared is 1. So this is just 30,000 times pi over 36. And let's see, I can take out 6. Yeah, take out a 6. And this would be 5,000. Oh, I can take out a 2. So it'd be 3 and 2,500. So it's 2,500 pi over 3. feet per second. Okay, and that's it. Okay. Hope you found that helpful. I will see you on the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.